The first problem on the circle equation homework says to write an equation in standard form of each circle graph below. Okay, so the big thing is that the two things you need to know in order to write an equation, you need to know the center. So the center is at -2, 2, right? So my center is at -2, 2. And then we need to know the radius. So the radius is always from the center to a point on the edge, right? But if I notice, I don't have an even way to count the blocks over to the edge, right? 1, 2, 3, 4, and a little bit more. And it's just not good enough to estimate. But here's the thing is that I actually have a point right here. So from the center to the edge, right? That is a radius. Like that's one length. So the problem is I can't just count over. So to figure out my radius, I actually need to go way back to middle school and think about the Pythagorean theorem. I can make a right triangle right here, and I do know how long it is from here to here. See, this is at -2, right? -2. And this right here is at -4. So it must be like every 2 blocks is a 1, right? So from -2 to -4, this means that side of the triangle is too long. And from here to here, 3 to 2, this side of the triangle is 1 long. So I now have enough information that when I use Pythagorean theorem, a squared plus b squared equals c squared, I can find out how long my radius is, right? So a squared, it doesn't matter as long as they're both legs, which one's a or b. So I'm going to say 2 squared plus 1 squared equals c squared. And then 2 squared is 4, 1 squared is 1, then 4 plus 1 is 5. So I now know that c squared is 5, but I want how long c is, how long that hypotenuse is. So you square root both sides, right, to get rid of that squared. So c is actually equal to the square root of 5. Now you can plug that into your calculator if you want an approximate. If I type in square root 5, that gives me 2.236, but this is irrational. If I did that, I would be rounding. I would have to say c is approximately 2.236. But I don't want to do that. I don't want to weaken my statement with approximation. So I'm going to just stick with square root 5. Just leave it like that. So I now know that my radius is square root 5. Okay, so that's enough information to write the equation in standard form, because the equation in standard form, remember, we just always have x minus x and then something squared plus y minus something squared equal to the radius squared, right? The radius squared. So now I just kind of need to fill in the blanks. My radius is square root 5, so square root 5 squared. And then my center, it's x, and then you really take the opposite of this, right? X minus -2, which is the same thing as x plus 2. And y minus 2. So remember, it's kind of like the opposite. X plus 2, y minus 2. This squared equals square root of 5 squared. And if you leave it like this, that's okay. I'm actually going to take it one step further, and I'm going to do this. I'm going to simplify square root of 5 squared. The squaring and the square root undo each other. So that leaves this equation, x plus 2 squared plus y minus 2 squared equals 5. So this is the best version of standard form, where you can easily see the center and you can see the radius. Now you do this one. Notice this one's also going to need to use Pythagorean theorem to find that radius. And then this one, and this one's easier on you. You should be able to just count that radius off. Just remember to be careful about your scale. These use every 2 as 1 block. So it counts 1, -1, -2, -3, -4, right? Same thing here. 4, 5, 6, 7, 8. Okay, so just careful of your scale when you're doing those.